You ever wonder what it really takes to prove a world-changing idea? Well, today, we're going to journey deep into the Brazilian rainforest to meet the man who found the crucial evidence for one of the most famous theories in all of science.
So let's start with this question. What's the difference between a great idea and an actual scientific fact? It's not just about how brilliant the idea sounds, right? It's about the hard, verifiable proof that backs it up. And that is the real challenge.
Okay, so picture this. It's 1859, and Charles Darwin just drops a bombshell on the entire world with On the Origin of Species. It was this incredible, revolutionary argument for evolution, a grand vision for all of life. But it was still just that, an argument. The scientific community was definitely intrigued, but they needed more. They needed cold, hard facts. And this is where the hero of our story comes in. A man who would take up Darwin's challenge from halfway across the world and, honestly, change the course of biology forever. Meet Fritz Müller. He's a German naturalist who decided to trade in Europe for the vibrant chaos of the Brazilian rainforest. And for Müller, this wasn't just a new place to live. It was the ultimate laboratory, a living, breathing library of evolution right at his doorstep. And here's the thing you have to understand. Darwin himself, the father of the whole theory, he recognized Müller's genius. Once they started writing to each other, Darwin dubbed him the Prince of Observers. That's kind of like getting a glowing performance review from Shakespeare himself. Okay, so how do you even begin to prove a theory as massive as evolution? It seems impossible. But Müller's brilliant move was to focus all his incredible powers of observation on one small, manageable, but super complex group of animals, crustaceans. He basically turned the entire Brazilian coastline into his personal research station. And this is where we get to Müller's big, beautiful idea. He thought, okay, if Darwin is right about common descent, then the way we classify animals based on their similarities, grouping them together, that should be a perfect mirror of their actual family tree. The classification and the genealogy should be the same thing. It was a simple, clear, and most importantly, a testable hypothesis. And this is where it gets really, really cool. This is his method. He decided to treat Darwin's theory like a treasure map, a genealogical map that could actually predict what the crustacean family tree should look like. Then he went hunting for clues, but not in the adult animals. No, he looked at their earliest embryonic stages. His logic was simple. If the clues he found in the real world matched the map's prediction, then he'd have his proof. See, this wasn't just observation anymore. This was a detective story. So this right here, this is Müller's starting point, a theoretical family tree, all based on Darwin's ideas. He wasn't just wandering around collecting stuff randomly. Nope, he had a plan, a specific prediction he was testing. He was going to hold this hypothesis up against nature and see if it blinked. And then he found it, the smoking gun. It was called the Nauplio larva. What he saw was that animals that look wildly different as adults, crabs, shrimp, even barnacles, which everyone thought were mollusks, they all started their lives looking like this one single common little guy. It was just undeniable physical proof of a common ancestor. Exactly what Darwin's theory predicted. A true aha moment for all of science. So Müller knew he was onto something absolutely massive. He took all of his evidence, all his arguments, and this really elegant deductive reasoning, and he put it all into a short book that was about to shake the scientific world to its core. And he called it, simply, For Darwin. For Darwin, that's it. The book was so groundbreaking that Charles Darwin himself paid out of his own pocket to have it translated into English. He even added his own notes and, with Müller's blessing, retitled it Facts and Arguments for Darwin. And the book was an instant sensation. A review from the time called it a remarkable example of important conquests. People got it right away. They realized Müller hadn't just found a bunch of new facts. He had pioneered a whole new way of doing science. He was moving biology from just describing things to actually predicting them. This timeline really puts it into perspective, how fast all of this happened. In just a few years, Müller goes from being a pretty much unknown naturalist in Brazil to becoming Darwin's most trusted collaborator. They wrote letters back and forth for the next 17 years, forging this powerful intellectual partnership, and they never even met in person. So, when you boil it all down, what's the big takeaway from Müller's story? What is the real lasting legacy of this prince of observers working from his remote corner of the world? Well, his impact was just huge. He didn't just support Darwin's theory, he gave it the factual backbone it so desperately needed. He basically invented a whole new way to study evolution by looking at embryos. And he didn't even stop there. He also did foundational work in other fields, like his famous discovery of Mullerian mimicry in butterflies. The man was a powerhouse. In fact, Miller's work with those crustaceans led directly to this profound new idea, the biogenetic law. The basic concept is that an animal's development, from a single cell to a full-grown adult, is like watching a speed run of its species' entire evolutionary history. It's like watching a movie of millions of years of evolution on fast forward, and Fritz Miller gave us the ticket to the show. So as we wrap this up, let's just take a moment to remember Fritz Miller, the quiet observer who changed the world from a small town in Brazil. And it really makes you wonder, doesn't it? Who are the Millers of today? Who is out there right now patiently and meticulously gathering the data that's going to spark the next great scientific revolution? And maybe more importantly, are we paying attention?